Okay, so succession is just basically the order or progression of different types of species that typically takes place when you have a new, in this case, terrestrial environment. We'll talk about what happens on land first. And there are really two types, one of which is primary succession. Primary succession is pretty rare, actually. It's only going to occur when you have new land formations, such as a volcanic eruption, and you've got you've got lava flows that cool and solidify, and you've got new rock there. Or you may have a case where from a mudslide or some other type of event where something completely washes out the soil. So that's a primary indicator, primary property of something that it is, or a succession process that starts out as primary succession is the fact that it doesn't have any soil to begin with. Okay, so that makes things tough for most organisms. However, there are some types of organisms that are called pioneer species that can survive in that particular situation. So as long as you have a piece of rock, part of the lithosphere, crust of the earth, and you've got water, of course, you need that. So typically that rock is going to need to be either flat so the water can settle on there for a little while, or even better, maybe have some cracks in it and stuff so the water can settle down in there and not dry up immediately or not run off the face of the rock as well, because of course you need to have water. And there are spores for many different types of organisms in the air, plants, etc., lichens, moss, and those kind of things. Like I said, some organisms in particular can take advantage of just having that water there and having the mineral from the rock there as well. Lichens are an example of this, and lichens in particular are effective as pioneer species in that they're actually a mutualistic, what we call an endosymbiont, which just simply means that they are organisms with the cells of other organisms inside their cells. Coral is an example of this, because coral is an animal, but it has algae cells inside the coral cells. That's what gives it its colors and stuff like that. It also helps it to be able to survive in low nutrient conditions. Well, lichens are funguses with algae cells inside their cells. And it's what gives them their variety of colors, just like the coral, the algae gives it those colors. Lichens also come in a variety of colors. And because you have a producer and a decomposer, you have basically a whole food chain. You don't really need the consumer part. Technically, the fungi is a consumer. It will consume the sugar that the algae makes, and then it will break down the waste from both the fungus and the algae into minerals that the algae can then absorb like fertilizer. So we know the whole food chain and the relationships that we have there, and that is fulfilled in the lichens. And moss in the same way, maybe just from debris and stuff that comes in. They're a plant, they're a producer, but they also can survive off of small amounts of minerals dissolved in the water. But the point being is that them being there, one of the things that they do break the rock down both physically and chemically, and into smaller pieces, also dissolving some of the minerals of the rock in the meantime. And another thing that happens, of course, these things being living organisms, and they produce waste. They produce organic waste, and that will build up in there. So you've got the bits of rock and things, you've got water, you've got the lichens and the mosses and things like that, and you've got the organic waste from all those. That basically will make a thin layer of soil. Okay. So once you have soil, now we're ready for what's called secondary succession. And the reason they make that distinction is because a lot of times you will have processes, as we'll see, both natural and things that people do, that will take out all the producers in an ecosystem and leave nothing but the soil, or take out big patches of those producers and leave nothing from the soil. So this is actually, secondary succession is a much more common process. And like I said here, once you've got a thin layer of soil from primary succession, you start this process as well. So with a thin layer of soil, or at least some soil, but maybe not a lot, grasses can take root. They don't need deep soil to root into. That'll be your first type of species that you tend to see. And then from there you'll have small shrubs or brush. There's another word for that. Plural. And they can root in somewhat deeper soil. So the grasses, now the progression here is the formation of soil. So the grasses, once they're in place, they're going to attract insects and birds that eat the seeds and rodents and things like that. Those organisms, those consumers that come along to feed on the grasses, they're going to leave their waste products behind. That's going to build up the soil some more. The grasses themselves, most grasses are annual grasses, which means they die off seasonally, and therefore that dead part of them will become part of the organic content of the soil. And that'll build up until the soil is deep enough to support shrubs. And then the same thing, shrubs and small bushes and stuff like that, they offer more cover. A lot of times they'll have fruit and things like that go along with them. You're going to get more organisms, more consumers in them to feed off of that, to find shelter in that. They're going to produce more waste. It's going to make the soil thicker and so on. And that'll progress to softwood trees. And softwood trees are just a variety of trees that, as the name implies, that they're not very dense. And the reason why they're not very dense typically is because they grow fast. And so they'll come in and they'll grow up and mature in 15 years or so like that and get to be good-sized trees from there. And then after that, you have also hardwood trees. And hardwood trees take longer to grow, but eventually, because of their ability, some of the things that they do, they're able to basically take over and displace or replace the softwood trees and shrubs and everything that are there. When you get to that stage, it's what we call a climax community. So it's kind of at the end, so to speak. Okay, but I don't want you to get too caught up in that, because it seems this might lead you to believe that this is what always happens and you always have that, etc. But if that were the case, then the whole world would be covered in hardwood forest, except for areas where they've been cleared out and stuff, which is not the case. So this whole series of events, how fast it happens, how fast the soil builds up and everything, is going to be dependent upon a number of things, climate, and the primary component of that climate, of course, is water. So how fast it happens, and also how far it goes. Okay. So like I said, we don't have forests all over the world. Even if it weren't for human impact, we wouldn't have forests all over the world. Some areas are grasslands, some areas are deserts. So the main thing that will kind of halt this process at some point is going to be how much water is available. There's other things too. For example, in the grasslands, water's a big part, because grasses don't need as much water as trees and shrubs. But you also have periodic fires. That'll knock them back. You also have animals that graze in those areas. So grazing herbivores, that's a big part of it as well. So as we'll see, that you can break this down based on how far it'll go. We break those down in what we call biomes, and we'll talk about that maybe today. But that's what this is leading to. Okay. Now, not only do not all ecosystems, not all environments progress all the way till we get to this hardwood forest kind of situation. Those that do, when you have a hardwood forest, or what's sometimes called an old growth forest or things like that, it's not always going to stay that way. And there are a number of natural as well as human things that happen to clear things out, to reset it, so to speak. Fire is a big one. As I said, in the grasslands, fires are frequent, and consequently, if you had little shrubs and brushes stuff that were growing above the ground, they would get burnt up in that process. Grasses, on the other hand, they're adapted to that. They have root networks and stuff that are somewhat protected from the fire. So weather, like storms, etc., whether hurricanes or windstorms, just general windstorms, tornadoes, things like that, they'll break apart and kill the older, weaker trees and things like that. You have foundational organisms like elephants and stuff that can come in, termites, termite infestation, disease, other things, anything that can wipe out large portions, not all of it, because you go too far, and of course that's you're not going to have recovery, but large portions of the primary producers of the trees that are in that area. And of course, humans. This has been a big one for the past 1,000, 2,000 years of people going in, clearing out forests, and using them for agriculture. So that, of course, would be a big one. Okay. Now, under natural conditions, of course, once these events take place, then nature gets back to the way it normally was, and you go through the whole process of secondary succession again. Grasses come in, followed by trees and shrubs and things like that, or bushes and shrubs, and then fast-growing trees, and then slow-growing trees. So there's a cycle that is common there. Now this actually is a good thing. We don't tend to think of fire and trees being destroyed and all those kind of things as good things, but in an ecosystem, a hardwood forest type ecosystem, one of the things that happens is that all the nutrients get bound up in these trees. You get somewhat of a monoculture. In other words, you're going to have one predominant type of tree species and not many other kind. And also, you are limiting other types of plant life because no sunlight can get down to the forest floor. And so it's not as, they're diverse ecosystems typically, but it's not as diverse and productive as it could be. So when these things happen naturally, it actually allows for other species to come in, to have their time, so to speak, while it goes through this whole secondary succession process, and it has been considered to be actually a good thing for ecosystems in general. And another thing we'll see when we look at forestry and stuff like that is the fact that it is, in the case of fire, natural fires tend to burn out the right amounts of woodland areas and stuff like that, whereas when we do certain things to try to manage these things, we end up having fires that will get out of control. But fire is very common. Fire is not just limited to grasslands. Pine forest, like we have in Florida, and of course California, those are the main areas you'll hear in the United States that have natural forest fires that happen. A lot of times they're set off by lightning, and those are both pretty common in both of these areas. And pine is very flammable, has a high sap content that makes it very much more flammable, and it can tend to take off. So Florida's always had a kind of ecosystem that was designed around that, or evolved and adapted around that. As a matter of fact, there's several tree species in Florida, probably also in California, and other areas that this happens to. But there's a number of species that actually won't even germinate unless the soil temperature gets up above 120 degrees Fahrenheit. You're not going to get that hot unless there's a fire. So they're actually adapted to having those fires and then coming up and doing their growth thing and all those other kinds of things all the way through. So keep in mind that this kind of thing happens, and it's a good thing. Of course, like with the anthropogenics, when people do it, the problem there is we tend to stick around for a long time. And so we'll convert over farms. In the past, actually, not as much as well, because one of the things that happens when you farm an area, if you don't have chemical fertilizer, is that eventually the soil will no longer be productive for your crops, and you move on. You let it lay fallow, or you just abandon it and go to another part of your property and farm that area. Nowadays, we have industrial farming where they don't do that. They set aside thousands of acres, they farm it as much as they can, and when the soil starts to give out, they just add chemical fertilizer to it. So we'll see some of the things that have happened with that later when we talk about agriculture, but that's part of this whole process. Now, aquatic succession is somewhat similar, but there's some definite key differences. The main pioneer organisms that you'll have when you have a new body of water is algae and bacteria. The spores are in the air, they're in the soil. It doesn't take very long at all before you'll get high growths of either one of those in a body of water. If any of you have pools at your house and you let the chlorine levels drop down for a short period of time, the whole pool will get filled with algae very quickly. And there's bacteria in there too, by the way. So it doesn't take long for that to happen. Another input that most bodies of water have is that they have runoff that's constantly bringing nutrients into it. So typically what's going to happen is that over time, these nutrients and sediments and things like that, they wash into the lake and they will slowly fill that lake in. It'll become more and more shallow. As that process is happening, because those nutrients, of course, are going to fertilize the system, you will have more and more organisms that start to live in there. Plants, insects, fish, other kinds of things. I think I may have mentioned to you guys that one of the ways in which these things get transferred from a lake that has stuff in it to a lake that doesn't is that wading birds, like herons, will wade around in the water and they'll take off and they'll have eggs and spores and other kinds of things and insect larvae and things attached to their feet, and they'll land somewhere else, and then these organisms in a new pond with no competition, they can spread out and multiply very rapidly. So that happens typically, and you end up getting now in nature, this happens slowly. And because it happens slowly, you have a lot of opportunity for a wide variety of things to meet their niche, to find their spot, so to speak, both physically and their area and their spot in the food chain and things like that. And you end up getting a wide variety, high biodiversity of things happening. This is different. It ends up becoming eutrophic, which actually in this case is a good thing. This is different than when things happen where people, for example, introduce a lot of chemical fertilizer into it and the algae just grows very rapidly. It takes over everything, the bacteria as well. So I want you to make sure you understand that this slow, ongoing process actually does produce a lot of biodiversity. And eventual end state for this, which you could call climax humidity for an aquatic ecosystem, is a wetland, where it's actually completely filled in. Okay. But just like up here, just like things don't always go and become hardwood forests, lakes and bodies of water don't always end up becoming wetlands, because there's a couple factors there that affect that. Temperature. It's going to have a lot to do with it, because algae and bacteria, they're very dependent upon certain temperatures. The warmer it is, the faster they'll grow. Cold areas, it may take hundreds or maybe even thousands of years before you'll start to get considerable growth in a new body of water. Okay. Another big one is how much runoff does it receive? How much natural runoff does it receive? In Florida and a lot of places around the world, your lakes and your ponds and things like that, they are in the low-lying areas. So naturally, as it rains and things, water washes sediments and nutrients off into them. But there are some bodies of water, what we call alpine lakes, lakes that are up in the mountains, that's not going to be the case. They're up high, so they're not going to have as much flowing into them as in the way of runoff. And example of that is Crater Lake in Oregon. Oregon, whatever, however you want to say it. But that is a lake that is from a caldera of a volcano, not unusual, or a dormant volcano. It's got kind of like a bowl at the top, and basically water fills it in. Water there is beautiful, extremely clear. Not a whole lot around it as far as cliffs and everything to run off into it. So that's another thing that makes it have a lot of clarity, is it doesn't have a lot of runoff. But it also doesn't have a lot living in it naturally. Now they have stocked that lake. The Parks Department decided, they wanted to have fishermen and things come there and generate some revenue that way. So they've stocked it with fish, which they have to feed and everything else. But otherwise, prior to that happening, like I said, beautiful water, probably good quality to drink, but you don't find a lot of things living in there. There's not enough nutrient input. Plus it's cold. That's another. And then finally, flow. A lot of lakes have water flowing through them. A lot of them are rivers that have just broadened out. Some of them have springs that are feeding them from the bottom. That's a common thing here in Florida. And so consequently, if you have water flow through a lake, it's going to wash out the sediments, at least in part of it, usually out in the middle, of course, and therefore it's not going to fill in. It's going to wash those away, and you will have a regular lake. But a lot of times you'll have that succession and filling in with plants and reeds and stuff like that along the edges of the lake, where the flow is not washing out sediments so much. And so that's the kind of lake, and that's the common kind of lake to find in Florida. And like I said, a lot of lakes are parts of river systems. Lake Monroe, Lake Jessup. Jessup? I don't like Jessup. It's Lake Jessup. Lake Jessup, Lake Monroe, Lake Harney in Geneva. Those are all parts of the St. John's River. They're just areas where the St. John's River is spread out. All right, so these different stages of aquatic succession are called oligotrophic, which means few food, really literally means few food. Few food chains would be a more accurate translation, I guess. Mesotrophic, which is kind of in the middle. This is where you categorize those lakes like I just described that have a lot of growth and stuff along the edges, but maybe the center areas and stuff like that are kept swept clean of the nutrients and sediments there. And then eutrophic ones, like I said, a naturally eutrophic lake, and you probably see them around. If you've ever seen a lake that might have a lot of lily pads, a lot of grasses and stuff growing up through it and things like that, that is a lake in the later stages of eutrophication. They're actually very productive. They're healthy ecosystems, healthy environments. They support a wide variety of microorganisms. Like I said, unlike, however, the kind of lakes that are what we call culturally eutrophic, where there's a lot of algae and bacteria, but not much of anything else. And I'll go into the cultural eutrophication thing a lot more later when we talk about water pollution. But these are the natural stages of a lake's succession out in the wild. Any questions? No? Alrighty. That's it for that stuff.